Hello, my dear viewer. I am grateful that you are meeting once again. Thank you for staying tuned to Edu TV. I am EJ Washington, and welcome to this chemistry lesson show. My colleague in the sign language doc is Maureen Njuguna. In studio with me to do this as usual is my chemistry resident teacher, Mwalimu.
Yes.
Karibu sana.
Asante sana.
You look very nice.
Thank you as always.
Welcome.
Yes.
Kindly say hello to the viewer.
Hello viewer, I'm teacher Mohinya RK, a teacher of chemistry. And today we are going to learn about water and hydrogen. This is chemistry form 1. Mr. Washington.
Wow, chemistry form 1. Today's topic is water and hydrogen. You know, Mwalimu, they always say water is life.
Yes.
Water is everything.
Water is everything.
Wherever you go, you meet water.
Good.
Underground, above the ground, in the atmosphere.
That's water.
Even in heaven.
Yes, in heaven there is water.
Okay, Mwalimu, so what actually would be the outcome of learning this water and hydrogen for today's lesson?
Yes, by the end of this lesson,
Yes.
you, my learner, you're expected to know the following.
Yes.
And you should be able to state the sources of water. You should be able to explain the physical changes of water. And you should also be able to discuss the properties used in determining the purity of water.
Wow, you heard that, my dear viewer. This is the time you grab your pen and your notebook, because by the end of this lesson, as Mwalimu has put it well, you'll be able to just state the sources of water, explain physical changes of water, and also you'll be able to discuss the properties used in determining the purity of water.
The purity of water.
Mwalimu, this is very interesting.
Yes.
Water is something we come across in our daily-to-day activities every now and then.
Yes.
And I think it is important for us to learn this much about water.
Yes, you know that water,
Yes.
in our earth crust, water is the most abundant substance.
It is.
It is. In fact, even the biology teachers they
Yes,
tell us
yes.
our body is about 70%.
Yes, I heard
can
that.
imagine.
I heard that, yeah. And actually, when you look at the globe, more of the earth is water than land.
And that's why we are saying about 71%
Yes.
of the earth's surface is
It's
covered with water.
71%
71%
is water.
covered with water.
That is oceans, lakes, rivers, dams,
All those.
those.
Covered with water. Yes.
Mhm.
And therefore,
Yes.
we have some physical properties of water.
Yes, actually, I was about to ask you that sometimes you can give me two chemicals that look alike. Now, how will I know this is water and this is not water?
You see, there's those things that you determine,
Yes.
that you use to determine whether there's water or not water.
Okay.
Because most liquids that you use in the laboratory, they are colorless.
They are colorless.
Yes. Most of them, they are tasteless. But remember, you're not supposed to taste anything in the lab.
Yes.
They are odorless. You know, those things.
Yes.
And also, they are neutral. And you realize even water itself
Yes.
go in that category.
Oh, water is also colorless.
Good.
That is true. And that, we're talking about pure water here.
Pure water.
Because the
Pure
water
water.
in my village, people from Kokwanyo Republic can tell you that their water is brown.
But still
That's
water.
what they're used to, seeing them in the rivers and the ponds there.
But still water.
But pure water is colorless.
Colorless. It's odorless.
It is odorless. It has
That's
no smell
no
whatsoever.
smell at all.
Okay.
No smell at all. Then it is neutral.
It is neutral.
Neutral means what in chemistry?
Yes.
Neutral means that if you test
Yes.
with the litmus paper, the litmus paper will remain its color.
Oh, so it is neither acidic nor basic.
It is there at the center. In fact, you talk about the pH of 7
Yes.
because it's neutral.
Okay.
Also, if you test with the phenolphthalein indicator,
If you test with
phenolphthalein,
phenolphthalein indicator.
Yes.
The universal indicator.
the phenolphthalein, there's also universal indicator.
Oh, so there's phenolphthalein.
Yes.
I hope you
Yes.
got that right.
Okay.
I'm struggling to get it,
Yes,
but I
also-
will by the end of this episode.
Good.
Phenolphthalein indicator.
And there's also
The universal indicator.
In fact, the universal indicator, they tell us the pH value.
Yes.
pH value of a substance. And the pH value of any neutral substance
Yes.
is 7.
Is 7.
And of course, water is neutral.
Yes.
So the pH value of water is what?
7.
7.
All right. And Any other property of
Yes,
water?
tasteless.
It's tasteless.
Yes.
Yeah.
Tasteless. And that's why, of course, we have said in
Yes.
the lab you are not supposed to do what?
To taste
Ati
water.
useme wacha nijue kama ni maji.
Yes.
Utakunywa acid.
No, you cannot.
uh.
And some people, they come to your house and they ask for drinking water. Then they tell you, "Hey, this your water tastes nice."
Good.
That is not pure water.
That's not pure. That's not pure water. Because water, as
Yes.
per chemistry, should be
Tasteless.
tasteless.
Okay.
Good.
And definitely, it's also a liquid, right?
It's a liquid. It's a neutral liquid.
Okay. Now, where does water come from? If someone asks me that.
So many sources.
Yes.
So many sources of water.
Yes.
In fact, even standard one
Yes.
child can
Yes.
give you the sources of water.
Yes.
But the main one that we know is rain.
Rainwater.
That's automatic. Rain is one of the main sources of water. Then you have springs, boreholes. You can mention others.
Lakes, of course.
Of course,
Yeah.
because I know you come from the other side. That's why you're saying that.
Yes.
Lakes, seas,
Seas.
all those
rivers.
Rivers. They are the sources of water.
Okay.
Those are the main sources of water that we, most of the people, they
Yes,
know.
we
Because
know.
of course, some people they do not know about lakes.
Of course.
They do not know about the rivers.
Rivers. So some people don't even know about springs.
But
Yes.
most of us they know about what? The rain.
The rain.
Good.
Okay. So those are the main sources of water.
The main
There
source.
could be other sources,
Okay.
but this is what we are used to.
Good.
Okay.
But remember, tap water
Yes. Yes.
is not a source.
But it is if I open my tap and the water comes out.
No, where's the original?
Oh, the dam or the river or the lake or wherever.
That's not the source.
I get
The
you.
source.
Yes.
So student, do not write for us
Yes.
that tap water is a source of water. It is not.
It is not.
It is not.
Correct. Yeah. So once we've learned the sources of water, can we also mention what is used for?
Yes.
Yeah.
We have diverse use, many uses of water in our daily lives,
Yes.
in industries, in all the areas.
Yes.
We have so many uses.
My main use of water, me as an individual,
Yes.
my main use of water is drinking.
Drinking.
Yes, bathing comes number 5.
5 there. Eh? There's also cooking.
Yes,
I
drinking,
know.
then cooking comes
Yes.
next.
Mention the third one.
No.
Yes, there's cooking.
There's cooking,
There's drinking.
drinking,
Yes, there is bathing.
bathing, hygiene. That is
You
there.
know, you are mentioning according the two
Two
priorities.
priorities, yeah.
Yes.
Hygiene now includes washing,
Washing,
cleaning,
all those things.
Yes.
There's farming.
Oh yes.
Farming.
Irrigation
Remember, what you cook at home comes
has
from
to be
the farm.
farmed. Yes, that is true.
The irrigation, those drip overhead, all those things, that's irrigation.
Yes.
There is also cooling of engines.
Cooling of engines.
Yes, engines.
That is a very personal use for me. I should have mentioned that.
Share with me.
I share with you.
Yes.
Where I come from, we have these diesel engines. We call them kisiagi, the posho mill,
Yes.
for grinding maize into flour.
Yes.
Now, the posho mill has a water tank outside, which is used to cool the machine.
The engine.
The
itself
engine.
now.
So if you're my friend, if you are unlucky, by lunchtime you've not ground your maize and the engine is hot, it has to be turned off. If
go
sometimes
with
the
your
water
maize.
goes also, it becomes very hot. They have to wait for that water outside to be cool, so that it can be able to also cool the engine in time.
Again,
You will miss lunch.
Which get there?
Or wait for supper
You
altogether.
wait for supper.
Yes.
Yes, cooling
So
of engine.
cooling
the vehicles,
engine,
the
even
vehicles,
vehicles,
they have
yes.
water system there in the carburetors.
Yes.
Therefore, water can also be used
Can
in
be used.
cooling of engines.
Yes.
In the, we have generating of electricity.
Yes. Yes.
The electricity that we use in our homes.
Yes. Most of it comes from hydroelectric power.
Good hydroelectric power. From a single all the way. We get that electricity from water.
From water.
And we have already said irrigation.
Yes, we said irrigation. Can I mention just one?
Yes.
A quick one that we also do the other side. We also use water for transport.
Good. I didn't mention it.
Yes.
But it's also a very good use.
From Kisumu to Kindu Bay. Via Maji. Shortcut. Shwa, I am there.
even from one continent to another.
To another continent,
You
yes.
use the ship and then you're able to land the other side.
Yes.
Even dyeing, bleaching, we
Okay.
also use water. So it means water has so many uses.
I see.
Yes, we cannot ignore water.
Water.
Yes.
Okay.
So this water we are talking about, in our laboratories, remember
Yes.
this chemistry lesson?
Yes,
You
yes,
might
yes.
diverse to agriculture or biology.
Mm-hmm.
In this chemistry,
Yes.
this water dissolves many substances.
Uh-huh.
If you put sugar in
It
water,
will dissolve in water.
dissolves.
Salt.
Salt
Mhm.
dissolves in water.
Yes.
Flour.
Flour. No.
Good. Flour doesn't. Therefore, we have so many solids which dissolves in water.
Mhm.
So we can call water as universal solvent.
Oh, it's a universal solvent.
Yes, because most or many substances
Mhm.
they dissolve in water.
The substance will be called solutes.
The solute.
Yes.
Exactly. In chemistry now we call them solute.
Solutes.
And the water now is the
Solvent.
solvent.
Mhm.
So water can be called a
universal
universal solvent.
solvent. Okay.
And of course this water we are talking about, like this one that you have here, about 35%. It's oxygen. Dissolved oxygen.
Okay, I know water consists of hydrogen atoms and oxygen atoms, but I've never known the capacity or the ratio.
Yes, the oxygen we have dissolved oxygen, and that's why
Yes.
animals and plants
Yes.
in seas, lakes, oceans, they're able to survive.
To survive.
And that's what we are saying. Oxygen supports aquatic
Life.
life, what you are calling aquatic fauna and flora.
Oh, plants and animals.
Good,
Mhm.
because we have what? The dissolved oxygen. And if you boil that water, by the way, you are eliminating. You are eliminating the oxygen gas, and therefore those animals cannot be able to survive.
To survive, I see.
Yes.
Like recently, there was a story on the media that fish are just dying in Uganda. That Lake Victoria, the portion of it in Uganda, has been contaminated. So that means the oxygen has been interfered with. Something
It cannot be able.
they can't breathe.
Yes.
The fish, so they end up dying.
Yes, the oxygen cannot be able to penetrate through,
Oh.
and therefore they die because of
I-
that.
I see.
And this water naturally exists in 3 states: the solid, liquid, and gas.
Oh, we are only used to water in the liquid
In
state.
the liquid state, in
Yes.
most cases.
Yes.
But even right now in this room where we are, we
Yes.
have the gaseous state. Why? Because air contains what? Water vapor.
Oh, the vapor.
The vapor. So it means
I was almost running out. You're telling me there's water in the room, my friend.
it's a small percentage.
Oh, yes.
But you realize the water that you're talking about exists in 3 states.
3 states.
That's the solid ice.
Oh, the solid one we call ice.
Good.
The ice cubes.
Uh-huh.
Ice cubes.
Then we have the liquid water.
The liquid water.
Then we have the gaseous water.
The gaseous water.
What you call the water vapor.
The water vapor.
And these states can be converted. They are interconvertible. Convertible.
Interconvertible.
Yes,
Okay.
meaning you can be able to change from solid ice to liquid.
To liquid.
By doing what? Heating.
By
Then
heating. Then liquid
what-
ice to gas.
By heating.
More heating.
More heating.
Can we reverse?
Yes, we can reverse. That's what we are saying. They are
Inter-
interconverter.
Okay.
You can change from one state
From gas
to
now
another.
into liquid.
Liquid
Uh-huh.
into-
Through what process?
through the process we called from gas to liquid. We call it condensation.
Condensation.
Yes.
Uh-huh.
Then from gas, liquid
li-
to solid,
From liquid to
we
solid.
call it freezing
Freezing.
or solidification.
Or solidification.
But naturally, even in our normal life, we
Yes.
have what you call the water cycle,
Yes.
whereby
Mhm.
from our screen there we can be able to see
Yes.
the water cycle.
Mhm.
The water cycle starting from the oceans,
Yes.
whereby there's warm, the heat,
Mhm.
and therefore the water evaporates.
Evaporates. Yes.
And then from there, after evaporating,
Mhm.
it condenses as clouds.
So water in the ocean and lakes and seas exist in liquid state, right?
Yes, in liquid state.
Then upon
Solar
heating
energy from
the
the
solar
sun.
energy from the sun,
Mhm.
it evaporates,
Evaporates
into gas.
Into gas.
Uh-huh.
Then it
Where does this
condenses.
vapor go to?
That vapor now rises up
Mhm.
and then
Into the atmosphere.
condenses, yes, and condenses as clouds.
Okay.
Yes. Now that cloud is solid ice. We
Okay.
can call it solid ice now.
Uh-huh.
And then from the
Clouds are solid.
yes,
Okay.
yes.
We think solid clouds are like smoke.
No,
That's what we
it's
see.
water,
Yes.
especially when it is about to rain.
Yes.
It is heavy solid.
Yeah.
Heavy solid.
Uh-huh.
And then from there,
Uh-huh.
it can now start moving down.
Okay, the solid
When the
moves down.
temperature now starts rising again,
Yes.
it's kind of precipitate. it is converted now from solid to
liquid.
and falls as what?
As
rain.
Oh,
And then the process repeats again.
itself. So from the sea, it's heated, it rises up into vapor. The vapor is, goes high. So that's why they say higher you go, cooler it becomes.
Yes.
You know, when I was a child, I thought up there, because the sun, I see the sun up there, I thought it was hotter up there.
No, if as you go down, it becomes hotter and hotter.
Yes.
Yes.
So up there it's colder. So this vapor condenses into the solid. Then when it becomes heavier enough, it can't sustain itself in the air, it comes down.
It comes down as rain.
And as it comes down,
the temperatures are increasing.
So the solid now
converts
to liquid.
Good.
Yes.
And goes back now to the rivers, to the ocean.
Okay.
The process repeats
itself.
And therefore we are calling it the water cycle.
Well understood, Mwalimu.
Good.
Yes.
And we have already talked about that during evaporation, the water vaporizes up. All this we have talked about.
Yes.
And that's why we are saying that process repeats itself on daily basis.
Yes.
Even right now, there is that process which is taking place.
I was just about to ask, are there specific temperatures where now these states change?
Yes, yes. Already we said at 100 degrees Celsius, that's when we convert the liquid water to gas.
At 100 degrees Celsius.
Which is equivalent to 373 Kelvin.
Yes, I remember the conversion.
Yes.
373 Kelvin.
Yes.
At sea level.
At sea level.
Yes.
At sea level. That's when there's that conversion from liquid to gas. If it is from solid to liquid, it should be at 0 degrees Celsius.
At 0 degrees Celsius.
Which is equivalent to what?
273 Kelvin.
Perfect.
Yes.
273 Kelvin.
Yes.
Therefore, through that conversion, you're able to get liquid, gas, and solid as water. In those three states of water.
Yes.
And we have several processes. We have talked about them. Those several processes we have from solid to liquid. We call it melting. Yes. Whereby the solid changes. There's breaking of the board and changes from solid to liquid. Upon heating.
Correct.
Then there is liquefaction. Liquefaction is the same as what? Condensation. Whereby the gas itself, the water in gaseous state, when the temperature is lowered, it is converted to liquid. Okay, that process what you're calling condensation or liquefaction.
Okay.
If you continue cooling that liquid, it changes to ice, and that process is what you call what? Solidification. Or what? Freezing.
Mwalimu, is it possible to get it from maybe solid state straight to gaseous state and vice versa?
In water, no. Because water is not a sublimate.
Okay.
We have those substances which are converted from solid to gas.
Direct.
Through that process we call sublimation. But water is not a sublimate. Therefore, it has to pass through those processes.
The three states.
There's three states. From solid
to liquid and to gas. Wonderful.
When we are talking about the cloud, we have those minute, those small particles, solid particles, they float in the atmospheres.
Okay.
And we say they coalesce, they join together.
And they become heavier.
We have talked about that.
Yes.
And forms what you are calling the clouds. Then after that heavy clouds, temperature rises or beyond a certain point, those cloud now melts, and then from there it rains, or the water drops as the rain.
What happens in the cases of snow or even what they call ice balls, when sometimes it rains? We say cats and dogs.
Good. The reason we get those things is because the temperature has not reached the melting point.
Okay.
You see, from the clouds, it becomes a solid, but the temperature are rising as you go down. Therefore, there's conversion from solid
to liquid.
But there's somewhere the temperature is not enough.
It's not enough
to convert that solid into
into liquid.
And that's where
Yet,
you
yet
hear
the
the
solid
hailstorm.
particles are heavier.
Yes.
So they will through gravity it will rain either way.
Yes,
But
the
it rains
hailstorms,
the hailstones
you'll see them.
or
The snow.
the winter snows.
Yes, yes.
Okay.
And
Mwalimu.
this, we have already talked about this,
Yes.
about the conversion, the processes.
Yes.
That's from solid
Mhm.
to liquid
Mhm.
and to gas.
Gas.
We need to remember all those processes.
Yes.
The process of melting,
Yes.
the process of boiling,
Yes.
the process of solidification,
Solidification. Yes.
condensation,
Mhm.
all those processes,
Yes.
they occur in water.
In water.
Good.
And I think if you can put back maybe that slide again for the viewer just to see
Mhm.
and take notes, because I know it's very important for a viewer of this level of Form 1 to remind him or herself about those processes as you've mentioned them.
Good. Let's go it through very fast.
Yes.
We have the solid.
Mhm.
Upon heating,
Yes.
it melts.
Yes.
The process is called melting.
Melting.
Then if you continue heating,
Yes.
of course it melts to liquid,
Liquid,
or
yes.
to liquid
Mhm.
water.
Yes.
If you continue heating, that process, we call it evaporation,
Evaporation.
or vaporization. And you
Vaporization.
get a vapor.
Correct.
If you now start cooling down
that vapor.
that vapor
Mhm.
through the process we call liquefaction or liquidification
Mhm. Oh, liquefaction.
or
Liquidification. Either or is allowed.
Either. Or,
Okay.
or what we are calling condensation.
Condensation.
You get liquid water.
Correct.
If you further cool down,
Mhm.
you're going to get your solid back.
Wow.
So the process can repeat itself.
Yes.
How do we know this is pure water?
That's another thing I wanted to ask you. Because sometimes you just look at water and you see it's clean water. And I can say this is pure water.
Pure water
Yes.
has three criteria.
Mm-hmm.
Three criteria for you to be able to know this is pure water.
Pure water, yes.
If you're given this water,
Mm-hmm.
you take it through the three processes.
Okay.
Number one is
Yes.
to determine the density.
The density of water.
The density of water should be 1 gram per cubic centimeter.
The density
pure
of water,
water.
should be 1 gram per cubic centimeter.
That's pure water.
Okay.
Then you boil it.
Mm-hmm.
You boil it at sea level.
Okay.
Sea level. Sea
Yes.
level means 1 atmosphere. At
One-
1 atmosphere.
Okay.
So when you boil it at sea level,
Mhm.
it should be boiling at 100 degrees Celsius.
Exactly.
Exactly.
Okay.
Or 373 Kelvin.
Okay.
If you have to melt it,
Yes.
it should be melting at 273
Degree-
Kelvin
Uh-huh.
or 0 degrees
Celsius.
Celsius. Those are three criteria for determining
Determining
the purity
pure.
of water.
Wow, Mwalimu. This is very interesting, Mwalimu. My director already signals that our time is up.
But we need to leave to test our students.
Yeah, I
to
think
see.
let's give them a take-home an
Yes.
assignment to handle.
But before we test them,
Yes.
let them name 4
Uh-huh.
physical properties of water.
Okay, you
They are very
can
simple.
just take in them faster.
Mhm.
All
Those
right.
are the 4 physical properties of water.
We said it has to be colorless liquid,
Mhm.
odorless liquid,
Mhm.
tasteless liquid,
Mhm.
and a neutral liquid.
Perfect.
Mhm.
Then the second question
Yes.
to my learners:
Mhm.
mention the main sources of water.
Yes.
Mention the main sources of water.
That one I will not tell them. That one they will mention.
Yes,
Yes.
they are there.
Yeah, they are there.
Then
Yeah.
you are supposed to give us the criteria
Mhm.
of identifying this water is pure. There
Wow.
are 3 main criteria.
Yes.
Number 1,
The
melt at 0 degrees Celsius,
Uh-huh.
fixed. Remember, it's fixed.
Yes.
Then boils at 100 degrees Celsius,
Correct.
and then has a density of what?
1 gram per cubic centimeters.
But before we leave, we have to give you something to do at home, of course.
Yes.
Using kinetic theory of matter,
Mm-hmm.
discuss the 3 states of matter. 6 marks for that.
Okay.
The second question, explain the physical processes under which water undergoes when heated and cooled. Those are the 2 questions you are going to try at home.
At home. Wow, wonderful. Thank you very much, Mwalimu, for these incisive lessons about water. My dear viewer, that marks the end of our lesson for today. But remember, you can feel free to communicate with us on our social media pages, be it Facebook, Twitter. Our address is EduTV Kenya. You can tackle the assignment and send in and submit your answers, and Mwalimu will have a look at them. Otherwise, Mwalimu, we thank you very much for coming today.
Much welcome.
It has been wonderful to host you here, and we will have you another time again. Definitely.
I appreciate.
Well, dear viewer, that has been the Chemistry Lesson Show. And I have been E.J. Washington, and my sign language colleague has been Maureen Njuguna. On behalf of the entire team that has made this a success, we say goodbye.